Tina. I would like to discuss with you how to write ternary compound, but let us distinguish first a ternary compound from a binary compound. So I have here example of binary compound. Sodium chloride, it's binary compound, and then calcium sulfide. They are made of two different elements, sodium and chlorine. One metal and one non-metal. All of them, this is one metal and this is non-metal. Calcium sulfide, silver sulfide, that's binary. Zinc phosphide, another binary. Aluminum oxide, and strontium chloride. Suffix ends with IDE. It's all ends with IDE. The first syllable is the same, but the last part ends with IDE. That's binary. So, binary compound is made of two different elements. Okay, two elements, this is binary ionic compound made of two different elements, one metal and non-metal. How it is different with ternary compound? So, here is ternary compound, right here above. So, the compound name is ammonium phosphate, barium nitrite, ammonium sulfate, aluminum carbonate, iron hydroxide, potassium nitrate. With exception of hydroxide, because it's similar to this, the rest of them ends with ATE. ATE, ATE, and ATE. And then there is ITE also. Okay? That's the difference between binary. It is made of three different elements. Ternary compound is made of three different elements or more. Three or more. Alright, it's made of one metal and one polyatomic ion. And what are those polyatomic ions? We have here ammonium, we have here phosphate, nitrite, sulfate, carbonate, hydroxide, and nitrate. These are the polyatomic ions. And what are polyatomic ions? Polyatomic ions are a group of atoms that act as one and carrying a charge. Now, the rules in writing ternary compound is the same with binary compound. But there is difference here. This one ends with ATE. This one ends with ITE. What is the difference with that? With nitrite and nitrate, okay, why they are changing? Because most of polyatomic ions consist of oxygen with exception of few, like ammonium and cyanide. They don't have oxygen. The rest of them has oxygen. So when a polyatomic ion ends with ATE and the other one ends with ITE, meaning ITE has less oxygen. Here, let me show it to you. Nitrate, it ends with ATE, and then nitrite ends with ITE. It's made of one nitrogen and two oxygen for nitrate. And this has two oxygen and one nitrogen. So, less. Nitrite has less oxygen. Okay? Less oxygen. Look at sulfate and sulfite. Alright? It is ATE has 4 oxygen. Sulfite has 3 oxygen. Begin with ammonium phosphate. So, we are going to identify the cation. So, that is NH for 1 negative positive. And then PO4, that's the polyatomic ion, phosphate. PO4, 3 negative. Okay, the rule to apply here, when we have only one ion of polyatomic ion, if there's only one polyatomic ion, we are not using parentheses. But when it is more than one, we are going to enclose entirely the polyatomic ion in the parentheses. Okay, so no parentheses if it is only one ion, one polyatomic ion. So here, let's go back. So let's balance NH4 with PO with phosphate. So phosphate has 3 negative charge. Therefore, we need 3 ions of ammonium. So it's 1 positive NH4 positive. Okay, so we already have positive 3. That's the total charge. And then here we have negative 3. So plus positive 3 is equal to 0. What is the formula now? So we have now 3, 1, 2, 3. So we have NH. We have now, we're gonna write 3, and then we enclose entirely in the parentheses, and we're gonna put the subscript, which is 1, 2, 3. 3 atoms, 3 ions of ammonium. So we're gonna put here 3. Okay, and then we have only one atom of this. We just gonna write PO4. All right, so this is our formula, NH3PO4. We are not touching the number, the subscript of the polyatomic ion here. We are not touching them. We're not gonna change them because they are part of the structure of the polyatomic ion. So look at the answer, NH4PO4. Okay, I'll show you another one, barium nitrate. So we have Ba2 plus, and nitrite is NO2. NO2, 1 negative. So we have 2 here for barium, therefore we need to balance it with nitrite. So we're gonna make another nitrite here, 1 negative. Okay, when we're gonna sum up them, so their charges is now balanced. This is 2 plus, and then plus 2 negative gives you 0. So when you're gonna write the formula, this is Ba only 1, so there's no subscript. How many nitrite? So this is now more than 1, only 2 polyatomic ions. So NO2, you're gonna include its subscript because that's part of their structure. And then how many? 2. So put 2 outside, meaning to say we have 2 ions of nitrite. So barium nitrite, B. So that's the formula here. Last one, ammonium sulfate. So ammonium sulfate, NH4 negative 1, and then SO4 2 negative. Okay, so it has 2 charges. To balance it, we're gonna make this 2 also, NH4 negative 1, and then this is 1 only, so we have enough. Okay, so the total charge here is negative 2, and the total charge here is, oh, this is positive, I'm sorry. This is the only cation in the polyatomic ion. And then this is negative 2. So, plus is equal to 0. It's important that you know how to do this because we're going to use this later on. Therefore, what's the formula? Again, it is more than 1. Okay, so we are going to use parentheses. NH4, again, do not remove the subscript because they are part of its structure. Enclose entirely into the parentheses, and there is Na, sodium, plus 1 charge, and hydroxide ion, negative. So it's simple. Just write it NaOH because they are already balanced. And then this is sodium hydroxide. If you don't know the name, you just use the table of polyatomic ions. Now this one is strontium plus 1 charge, and then NO3 negative 1. So it's simple also because you have 1 atom of strontium to balance 1 atom of nitrate. So it's simply SrNO3. Okay, so this is strontium nitrate. And this one is silver. Okay, Ag plus, and then carbonate, CO3 2 negative. So we have 2 charges here, so we need 2 Ag here. Okay, 2 silver. and then it's already balanced. And then this is 2 plus, okay, plus 2 negative gives you 0. What is now the formula? We have Ag2 because there are 2 atoms of silver, and then CO3. You don't have to close in parentheses because we have only 1 atom of carbonate. So the name is silver carbonate. I'm sorry for my pen. I don't know what happened. I think I need to change the pin. Okay, so let me see if I have more example here. Yeah, there's one more example right here. At this point, you have the table here, and there's a rule here. Okay, so it's summarizing. So when you are watching, you pause for a while and watch the information. I just don't have long time to explain all of this, so I'm just demonstrating. Okay, zinc and dichromate. So dichromate is, we have here, so zinc 2 plus, and dichromate is chromium and oxygen. So we have Cr2. Remember, di means 2, and then O7, and then -2. So meaning to say, to balance each other, they need 2 atoms of each other. So it's going to be the same. So when you get it done, it's going to be 2 plus and 2 minus, it's equal to 0. So the formula is still the same. Just combine them together and remove the charge because it's already neutral, O7, that is zinc dichromate.